1, 0, -1, -2. We are live. Paul, how are you doing, buddy?
I'm doing great. How are you doing today?
Good. It's been a minute or two, huh?
Yeah, it has. I mean, yeah. Like
Or a month or two. Hey, so for our viewers and followers, welcome back to the DataCenter Podcast. Paul Smith-Goodson, the handsome one, is joined by myself, Matt Kimball. We did not talk to each other before we got dressed this morning to talk about all things data center. It's been a minute since we've been live, and we're down a man, so to speak. Will Smith, our friend and fellow analyst, has moved on to the independent game, and so that leaves Paul and I to pick up Will's slack, and we'll see how good of a job we can do here. But before we get into what we're going to talk about, just a couple of disclaimers, or one big disclaimer. Paul is one of the smartest people I know. I am not. Regardless of that, don't take anything we say as advice for investing or your financial good fortunes. If you do, shame on you, shame on you, shame on you. We like to talk about tech like we're sitting around Starbucks, which is where I'm at right now, and just give up opinions and offer up opinions. We are not offering any kind of advice whatsoever. Is that fairly said, Paul, or would you add?
I think you covered it, bud.
Excellent. Hey, so we have a lot to talk about today, quite a bit. We're going to talk about a partnership that was just announced between AWS and Cerebras. We're going to talk about power. We're going to talk about the power crunch, and we're going to talk about nuclear energy, which is all the rage nowadays. But let's start with AWS and Cerebras. So I'm going to set this up, Paul, and I'm going to want you to weigh in, and I'm going to go as fast as I can because there's a lot to this. So over the last 3 or so years, the AI discussion has been training. It's OpenAI, it's Mistral, it's Hugging Face, it's models, it's frontier models, and then we got into specialized models. And over the last 6 months or so, the conversation's been shifting from models, where you've got great repositories of data, trained data, and inference, where you make all of that data actually work across the enterprise. And training and inference are distinctly different workloads. And to take that a step further, inference is actually really two workloads working together to deliver an outcome. The first is when Matt or Paul enters a query into their ChatGPT or Claude interface, any natural language interface, to ask a question or do research. That's considered prefill. I'm going to ask you a question. I'm maybe going to upload some documents or tell you to go search to get some context for the question, but that's considered prefill. And that's a highly parallelized function. Kind of take all this data, move it into memory. And then the model does its magic work and it spits out a response to that question I have. That's called Decode. It's very serialized and it builds a response token by token by token. For those of you watching, Paul knows this, but for those of you watching or listening, when you think of, when you hear the term token, just think part of a word or part of an answer to a question, and all of these tokens get strung together to give you a response. But you can only generate one token at a time. So if a response to a question I have is 1,000 tokens long, you've got to wait for all 1,000 tokens to be processed or generated in a serialized fashion. So GPUs with HBM have a memory infrastructure called HBM that is really good at highly parallelized functions, moving a lot of stuff in and out simultaneously. But then you have companies like Cerebras that have built very specialized accelerators that do a really, really good job through SRAM, not HBM, SRAM, which is about 100 times faster from a latency perspective than HBM. These chips do a very, very good job of performing these serialized functions in a really fast function, orders of magnitude faster than what you can get on a GPU. So what AWS and Cerebras announced was they're going to take Trainium 3, which is got a huge HBM footprint, and the Cerebras CS-3, which is their wafer-scale AI system. They're going to connect them through a high-speed interconnect built on Nitro. That's an AWS tool, and expose this to Bedrock, where Trainium is going to use HBM to do your context setting, right? Your prefill, and Cerebras is going to be used to do your decode, to answer the question in a super fast fashion. They're claiming it's going to be the fastest cloud-based inference on the market by orders of magnitude, really easily used directly or consumed directly through Bedrock, the AWS AI system. And it's just there. Going to be really interesting. This is, to me, kind of, before I let you jump in here, it just proves a couple things. Number one, the inference market is wide open. And number two, inference is going to be served by companies that, the mainstream is not always familiar with. NVIDIA has gained the headlines nonstop. AMD has as well. AWS, Google, and Microsoft have got some attention with their AI chips. But companies like Cerebras really can change that inference game considerably. So I'm going to stop there, Paul, and let you weigh in on with your.
I've always been impressed with Cerebras. I mean, they got like I think around 2,500 tokens per second or something up in that area, I think.
Yep.
I haven't followed them recently, but I know that it's almost like instant response.
Yeah.
You get full reasoning really fast, like under a second. Not multi-step delays or anything like that. I think they do a really good job. I just had a visitor come in here, my dog Kyle. He's going to stay here for a couple minutes and he's going to want out again.
No, that's awesome.
AWS is bringing Cerebras on. I think it's a good decision.
Yeah, I really like it. What I like more than just, hey, here's another accelerator you can use in your catalog. I like how they've worked together to build this deeper level of integration through Nitro and Bedrock to deliver like this wholly integrated offering to consumers, right, to developers. Make it really simple to consume, really simple to use. And if you're following it home, right, kind of wondering like, well, what does all this mean, right? If you think about the types of generative AI that are being deployed across the enterprise today, it's chatbots, right? The interactive assistants where you're constantly going back and forth with the chat GPT around, create this piece of content for me, clean it up, make it cleaner, make it cleaner, make it cleaner. This iterative process that you go through, code generation, reasoning as you mentioned, agentic, where you've got this proliferation of kind of functions that are being spun off one after another. That's where you really start to see the latency that gets introduced on traditional GPUs versus something like a Cerebras. And I think that's where, your users, it's funny, if you think about speed, right? We get used to, as users, a certain level of performance, right? Like if you told me today I could have a dial-up modem with 56.6K baud speed, and I could have it for free, I would laugh at you. I'd rather pay my $80 a month for my absolute best, right? People have become addicted to speed and responsiveness. And that's what we're seeing with Cerebras and responding to this, to inference. Customers or business users aren't going to sit around longer than necessary to get the answers they need from that chat GPT-like interface that they're using for some business function. And I think that's where you're going to see this solution really take off in the enterprise. So, yeah, super fun stuff. Exciting to watch. I always worry about whether Cerebras has, not Cerebras, I shouldn't say that, but whether these chip startups have the ability to break through the noise and really create kind of some gravity, if you will, right? Cerebras has made this very easy to deploy. You know, their chips sit within standard rack form factors that can get plugged into the racks that are sitting in your data center. But also from a web or cloud perspective, this easy integration makes it a touchless kind of adoption for enterprise. So I think that's going to accelerate and really help Cerebras kind of, like I said, break through that noise that usually gets dominated by a few chip players. So lots of fun stuff in there.
Yeah, the implementation is pretty easy with Cerebras. I know. You put it in the middle of a bunch of hardware and
point your API at it, and away you go. Yeah. So good stuff. Anyway, really good stuff. Went live today. Look for deeper analysis from me later today, and then a research note sometime next week. With that said, let's move on to, because we're talking about AI, let's talk about something. I love your headlines. Let's talk about something that is on top of mind for everybody. Power crunch, not the cereal, but the disaster. Or cereal disaster. What are we talking about here?
That sounds like a cereal, doesn't it? Power crunch?
It does, yes. Captain Crunch's brother. Yeah.
Yeah, I got, I think everybody's interested in what the landscape looks like for power. The stats, I think very stats, but generally, data center demand in the U.S. is around 75 gigawatts, something like that. And it's a big increase from just a couple of years ago. It was like 15 or 20 gigawatts. So it's been a huge increase in demand on power and everything. And even from a global perspective, almost double since a couple of years ago. So it's all accounting, because of AI, and it's probably about 40% or 35% of that total. So, and what I understand, 2026 is going to be a critical year for power. It's basically where all the AI workloads have moved from, it's going from experimental status to moving it into full scale production. So a lot of that stuff's going to hit. That's going to put another additional load on the power. Did you say you were in Starbucks?
I am. Yes, I am.
I can hear your fellow customers in the background there. Anyway, Goldman Sachs says that their projection is that there's going to be a 165% increase in global data center power demand by the end of this decade. I mean, that's a huge load. So, and Gartner's got basically the same projections. They're going to jump something like almost 1,000 terawatts by 2030 in that area. So, there's massive projects going in right now. I know here in Austin, up in the Round Rock area, there's been a huge purchase for land that they're going to build AI data centers on, and I think that's going on all over the U.S. and all over the world, basically. So that's going to put additional load on the power. So I think Bloomberg said that there's about 150 new data center projects going on, and half of them are going to be over 500 megawatts. So.
Yeah, Paul, to what you're saying there, if I could add in before you keep going, it's funny, and there's a lot of talk around modernization to kind of drive down, existing data center footprints so that you can use your power more efficiently. But I look at that, and to me, that's like it's putting a Band-Aid on the bullet wound, right? I mean, there is so much. The AI infrastructure is putting such a demand on our power grid that even those modernization efforts don't quite, as good as they are, and as much as they help from a performance perspective too, they really don't address the power crisis we're facing adequately. And even if you look across the globe, like in South America, I did a piece on this a few weeks ago. If you look at like South America, there is so much power available in South America. And you look at a country like Brazil, not only is there power available, most of the power, I think it's like greater than 75% of the power generated comes from natural resources. It's like there's these huge opportunities to tap into that, but I don't think we've gotten our arms around it yet. So sorry, I just want to add in with that before you continue.
No, that's good. Yeah. Yeah, I know one of the problems right now is that a lot of the power grid, I mean, it's old infrastructure. I mean, it was built in 1950s, 1960s, 70s, and that era. So some of that stuff is getting close to end of life, and it's going to have to be replaced. In addition to the demand that we're putting on it. So it's not like installing a rack of modems or something. I mean, it takes 4, 5, 6 years to install a power grid. So, in addition to all the pressure, then we got the delay coming in. I really don't. I'd like to see a good study and see how all this correlates and how all the different variables are going to impact that and what we're going to end up in. And I haven't seen anything like that. So I'm going to be doing some research on that. And with all the new demand, of course, it's going to cause energy rates to go up, and they're projecting something like 10%, 8%, and high density areas. So
I'll be curious to see how this plays out because there are kind of a couple plays with AI, right? One is power, the other is sovereignty, right? You see the rise of neoclouds happening with AI infrastructure, and you think, okay, well, they're cropping up in areas where it's about performance or data sovereignty or cloud sovereignty, or perhaps where you can tap into power better, right, with dedicated AI infrastructure. But you also have companies like Equinix, however you want to say it, Digital Island, but then even more regional. And if you compare a neocloud, a CoreWeave to an AWS, you have these regional players. Like in Brazil, down in Sao Paulo, there's a company called Nextstream that does data center hosting. And it is to Equinix what a CoreWeave is to an AWS, right? It's that hyper or micro, if you will, focused data center operator. And it makes you wonder, do these kinds of players become a critical role in activating AI at a regional level, right? If I'm a global player, a multinational, and I have these AI initiatives, man, I would look at like a Nextstream as one of those places where I could drop my servers. They can manage my servers for me. They can host them, or they can just give me racks where I can do it myself. And they give me that hyper local experience. So the data sovereignty issues you might run into, even if you're running, Equinix or DigitalOcean in Brazil, you still have like the U.S. Cloud Act, which has implications, right? I wonder if these become outlets that companies can use to better meet their needs at the local level and distribute that power more globally instead of all concentrated in one spot.
Yeah.
Interesting, sir.
Yeah. The other issue, I think Microsoft is somebody's working on restarting 3 Mile Island. I don't know if you heard about that.
Yeah. Yeah.
That,
I, al- I always I always think of that Saturday Night Live skit, the Pepsi syndrome.
Oh, yeah. Yeah.
Instead of the China syndrome. Yeah, very interesting stuff. Anyway, it's going to be fun to watch. I mean, what do you think? What do you think happens over the next couple of years? I mean, are we running off a cliff, or do you see? Our next topic is kind of addresses this a little bit. Are things like SMRs kind of how we, kind of navigate these waters?
That's it's going to take a while. I mean, you're talking about SMRs right now. I mean, we're talking about a 2030, 2031 solution. So we're still going to have, I think we're going to have shortages in 26, 27 in that area. But what surprised me is I read a statistic on wind and solar and hydro that they supply, the figure I read was like 25% of the data center electricity globally, and that's growing at about 20% a year. I had no idea that it contributed that much.
How much of that do you think is, I'd be curious as to the distribution of that, like 20, let's say it's 25%, right?
Yeah.
How much of that 25% is where the big growth is, which is really the US, right? And maybe a little bit of Western Europe, but largely US, I guess Middle East as well. Where is that being supplied? Is that more the Nordics and kind of countries that have been or regions that have been very sustainability focused all along, or?
Yeah, I would think a lot of that would be over in Europe, and
Yeah, I would think so too.
It kind of got a head start on the hydro and wind and solar, I think. So that may end up paying off. Bottom line, I mean, it's power is going to be like a moat. If you've got access to electricity at a competitive rate, it's going to be a competitive advantage, because some companies are going to have to wait 4 or 5 years in order to wire it in. And so.
Yeah, what's funny, Paul, is when Jensen Huang, the CEO of NVIDIA, when he talks about the AI stack, he talks about 5 layers. You've got apps on top, and then you've got models, you've got apps on top, then you've got models, and then you've got kind of the data layer where, data feeds the models. Then you've got infrastructure, that's your, 4th, which is chips and data centers. He specifically calls out power and infrastructure, like infrastructure, not servers, but like data centers and such, and cooling as the foundational layer to the AI stack. And I think it's pretty telling that he does that, because it forces us to think about how critical that foundational layer is to making everything else work. Without power, you don't have AI. Right?
That's right.
Yeah. So how are we going to solve it? Is it SMRs? I mean, what do you want to talk about SMR growth? How are we going to solve this problem?
Yeah, I got interested in, well, I mean, I've always been interested in SMRs, but there's Reuters is holding a SMR, basically kind of seminar industry gathering here in Austin on May the 11th and 12th. So I'm looking at that. And I don't know, maybe something you want to go to also, I don't know.
For sure. So before we get into, let's set the stage for what SMRs are for viewers. So if you haven't followed this, SMRs are real simple. By the way, I slept next to SMR for about 4 years on a submarine, although they didn't call them SMRs. That's what they were in function. They're small enclosed nuclear reactors. Don't require that can be buried underneath the ground, but really they deliver the best of both worlds. They deliver the nuclear power in a much cleaner way, and they greatly reduce the risk of like severity if something should go wrong. There's no pipes coming in, no pipes going out. There's no water cooling. These are truly self-contained, sitting inside of a big lead or something container that gets buried in the ground, and it's used. You can use these to generate hundreds of megawatts of power. Is that a fair description?
I think they classify going up to about 300 megawatts. So,
Yeah.
So you can stack them. The advantage, I mean, they're factory fabricated and they're shipped right to the site, like you said. So you don't have like cost overruns and stuff like that. So it's all inside the reactor, and they've got different kinds. I'm not familiar with all the kinds, but I know they've got water cooled, and they've got. I think probably most of them are probably water cooled. So.
Yeah, the good news is because these sit as, and they can sit as self-contained reactors. You know what you saw. We joke about 3 Mile Island, but what you saw there, you see at Chernobyl, is in the event of some kind of catastrophic failure, that that disaster stays contained inside the self-contained system. Number one, number two, because you don't need to have feeder or chilling tubes going in and out, the threat of contaminating groundwater tables, so on and so forth, those are greatly reduced as well. Like I said, I was in the submarine for 4 years. I slept next to reactors, and other than my third eye that's in the back of my head, I have no side effects whatsoever. So they deliver super clean power, and they are a really great response. How do you see this in terms of support, though? It seems like we had a pretty healthy nuclear, how do we say, ecosystem for education, right? You had the military that were training nuclear engineers. You had universities with nuclear engineering programs. A lot of that has gone away. How do you get the people and the resources to stand up, an SMR market in short order? Is there any shortcut you can take?
I don't. I mean, obviously it's a faster system rather than trying to build a huge power system on your own. I mean, it can be shipped. I mean, there's different kinds of. I know there's different kinds of these reactors. It depends on. They've got different cooling, and I think that makes it easier. They've got light water cooling, and that's pressurized water, and then they've got some alternative cooling designs. I haven't really looked into it too much, but I know it's they use like liquid metals, sodium, and they use gases and stuff like that. And they're safe, pretty safe. I mean, from what I understand. So, I think that's the wave of the future is going to be these small ones that you bring in and you stack and you right size it.
Yeah, I think I saw some static about a year ago. I haven't looked at it at all, but it effectively said that SMRs are interesting, but really even today there are only like a handful of active SMRs in production today. But I really do think that if we're going to be serious about this, we have to think about how we train people to support these, engineers to deploy these, the infrastructure needed to make SMRs work. It feels like that is wholly lacking today, and I haven't seen. I know there are companies out there that are looking at this, but it seems to me you have to accelerate kind of the people and the parts and everything else needed to make SMR actually production ready and sustainable out in the marketplace. Otherwise, you can't just deploy these things and say, okay, they're out there and away we go. You need all of that support ecosystem to drive it. I haven't seen that yet, so kind of curious how that plays out.
Yeah. Well, I mean, you can build another interesting thing. You can build an SMR grid, and from what I read, they said that the first grid is not going to be around until probably 2030 in that area. So there's going to be a gap. You know, you just can't order it and get it the next day. You know, so I think that's why some of the hyperscalers are looking at restarting some of the plants like Prefill Island.
Yeah.
They can get something online faster that way than they can by.
Yeah, I placed my order for an SMR on Amazon. Expected delivery date is 2031. So there you go.
Yeah. China and Russia I think they're ahead of us on this. They got a jump on us. I don't know how they did that, but I know they're ahead of us on the SMR area. So
yeah, I think China's actually ahead of us on a number of fronts, SMRs, and alternative energies related to hydro and solar and wind as well.
Yeah.
Interestingly enough, I mean, even though they use a whole lot more coal than we do, they're really investing into that renewable infrastructure.
Yeah. Well, at least it's not a solution. It'd be worse, if we didn't. So the SMRs, I think, are pretty economical. Don't take a lot of capital. I mean, I think it's a good solution. Probably the only solution.
Yeah, I think you're right. Hey, we're coming up on time here. I wanted to, before we go off, I know there's a lot going on over the next few weeks. Do you have any travel coming up or any events you're going to be attending virtually?
Nothing. I'll be doing some virtually, but nothing massive travel or anything like that.
Okay. And one last question. Any cool research you're working on or doing?
Yeah, IBM just worked on a project with something called a half Mobius. Did you read about that? A new molecule?
No.
And what's strange about it, they had to build it basically atom by atom. It's a brand new breakthrough area that may have an influence on what we do in the future. But they had to build it atom by atom. But it's kind of like a Mobius strip times 4. But you can have it left-handed or right-handed, or you can have one kind of like in the middle that you can have it do really strange things. I mean, like a Mobius strip, if you take a circle and run your finger around the circle, you make one revolution, you come back where you started. If you do the Mobius, you follow the regular Mobius strip around the path. You have to go around twice to get back where you started. Well, with this half Mobius, basically the topology is that you have to go around four times to reset it to the original position. So, yeah, but it's a breakthrough in material science. So,
man, I don't want to go off on another topic, but to what you're saying, I think IBM does not get enough credit for how much innovation they bring into the technology market. Everybody, I think a lot of folks think of IBM and they think of Z, which is great, but they think of it's been around for a long time, but they don't realize how many breakthroughs they actually deliver into the market that enables where we are today.
Yeah. So, and we're getting close to fault tolerance. So that when we get close to fault tolerance on quantum, that means that we're getting closer to a quantum-centric supercomputer, and that's going to be able to do a lot of really neat things and solve a lot of problems that we've been looking forward to solving. So.
Maybe on the next call we can talk about kind of the hybrid quantum classical approach to the real use for quantum in the enterprise. I think that'd be an interesting topic
It
to
takes
talk
a lot. It takes a lot. IBM just published a paper on, basically how you put these two technologies together. But it's kind of like, trying to run your Tesla on gasoline. When you've got classical and you've got quantum, and you're trying to put those together, there's a lot of differences in the technology and matching them up.
And that's why we have people like Paul in the world to make all this work, right?
Yeah.
Anyway, all right. Hey, listen, we have to wrap up here. We're coming up to the end. It's great to get back into the swing of things. And we'll be back in a couple of weeks, but until then, just have to close with what we started. Thank you for listening in. Thanks for taking part in this. And just please remember, what we say, what we posit, what we think is not intended to be taken as investment advice. If you do choose to invest, shame on you, and we will laugh at you as you claim these losses on your taxes next year. So, yes. And until then, thanks for chatting, Paul, and I guess we'll chat in a couple of weeks.
Yeah, good seeing you again.
You too, buddy. Thanks.